மாணவர்களின் சாதனையை போற்றும் SNS
Good evening. So in today's lecture series, now we are going to discuss about the response of a second order underdamped system. So when the damping ratio zeta is between 0 to 1, then the system is called to be a underdamped system. Now it is a complex system where you have both real and imagined power, and we have discussed this in our previous lecture series. So in today's lecture series, now we are going to discuss what is the response of an underdamped system for a unit step input. So consider the general form of our second order transfer function for a second order system, which is given by omega n squared divided by s squared plus 2 zeta omega ns plus omega n squared. Now zeta is between 0 to 1 value, so that's why we call this as a second order underdamped system, and the responses for a unit step input where r of s is equal to 1 divided by s. So therefore our c of s is equal to, it is omega n squared divided by s into s squared plus 2 zeta omega ns plus omega n squared. Now we have to apply partial fractions in order to split the terms. So applying partial fractions, now we get omega n squared divided by s into s squared plus 2 zeta omega ns plus omega n squared is equal to, it is a divided by s plus bs plus c divided by the remaining term, that is s squared plus 2 zeta omega ns plus omega n squared. Now cross multiplying the terms, so cross multiplying the terms, now we get omega n squared is equal to, it is a into s squared plus 2 zeta omega ns plus omega n squared plus bs plus c into s. Now put s is equal to 0. Now we get the value of a is equal to 1. Next, comparing the coefficient of s squared on both the sides of the equation, that is on left hand side and right hand side. So in left hand side you can see there is no s squared term, so it is 0 is equal to, on the right hand side it is a, the coefficient of s squared is a plus, and you can see bs into s, that is bs squared, so it is plus b, which implies b is equal to minus 1. Similarly for c we will compare the coefficient of s alone. So comparing coefficient of s, now we get again on the left hand side it is 0. So here you can see you have a s over here, so it is a times 2 zeta omega n plus c, so which implies c is equal to, so this entire thing it goes to the left hand side, so it is minus 2 zeta omega n, So we have found out the value of a, b and c. So substituting this equation, now we get our c of s is equal to omega, that is a divided by s, so which is nothing but 1 divided by s minus, so because b is minus, c is also minus, so taking minus outside it is minus bs, so b is 1, so I'll get it as s plus 2 zeta omega n, the whole thing divided by s squared plus 2 zeta omega ns plus omega n squared. Now next we have to find the response, so we have to take the Laplace inverse. So for this term we cannot directly take the Laplace inverse, so we have to do certain simplification for the second term on the right hand side. So first what we have to do is adding and subtracting this equation by minus, that is omega n squared. Sorry, it is not omega n squared, so it is zeta squared omega n squared. adding and subtracting zeta squared minus zeta squared omega n squared to the second term of this equation. So what we get is, so I am just continuing over here. So what we get is, we get our C of s is equal to 1 by s minus s plus 2 zeta omega n. Now the whole thing divided by, now we get s squared plus 2 zeta omega ns plus zeta squared omega n squared, and now I am subtracting minus zeta squared omega n squared plus omega n squared. So this term we can combine and we can write it as, it is 1 by s minus s plus 2 zeta omega n, whole thing divided by, so it is s plus, now I can see it is zeta omega n the whole square. So it is a squared plus b squared plus 2ab. So it is a plus b the whole square. And now here you can see omega minus omega n squared is common. So I am taking it outside. So I will get it as zeta squared minus 1. Zeta squared minus 1. So as, so it is s plus zeta omega n plus zeta omega n, the whole thing divided by, the whole thing divided by s plus zeta omega n the whole squared minus omega n squared into zeta squared minus 1. So we are just splitting this term and we are writing it as 1 divided by s minus s plus zeta omega n, this is one single term, divided by s plus zeta omega n the whole squared minus omega n squared into zeta squared minus 1. And then we have the remaining one. So it is minus, because minus is common. So minus zeta omega n divided by s plus zeta omega n the whole squared minus omega n squared into zeta squared minus 1. So then we have to simplify this equation. We have to take the Laplace inverse. So after taking the Laplace inverse, now we get the response C of t for this second order system like. So C of t is equal to 1 minus e raised to minus zeta omega n into t divided by root of 1 minus zeta squared into sine omega dt plus theta. So this is our final response of a second order underdamped system for a unit step input, and its response looks like this. So it is, you can see we have oscillation term, that is in terms of sine theta, and also we have a exponentially decaying term. So the response will be like this. So this is our response C of t with respect to time t, the response of a second order underdamped system, where most of our practical systems belongs to the underdamped system. So thank you.